Apologies for stopping in the middle of question 7. My video camera cut out, but we will continue. So Wn is equal to 0.5 Wn minus 1 plus 80 is equal to Wn minus 1. We can treat Wn minus 1 as a variable. So to keep things easier, let's keep that as x. So 0.95x plus 80 is equal to x. So when you evaluate this problem, you have 0.95x plus 80 is equal to x. So first of all, if we can subtract 0.95x from each side, and we can have 80 is equal to x minus 0.95x. So 80 can be equal to 0.05x. And we divide each side by 0.05. And 80 divided by 0.05 is equal to 1600. So x is equal to 1600. Wn is equal to 1600. Well, Wn minus 1 is equal to 1600, which is equal to Wn. So that is our answer. For number 8, value of the expression 200 times 1 plus 0.5 to the 10k, or 0.5 over k to the 10k gives the account balance. If $200 invested into account for 10 years, the account pays 5% annual interest rate, and that is compounded k times in a given year, what is the approximate value of the account as k approaches infinity? Alright? So that means that you have an infinite number of compounds. So one thing just have to know is that for an infinite number of compounds, your formula would become A is equal to PE to the RT. However, so if you know that, you can just say that you can evaluate 200 times E to the 0.05 times T, so it's by times 10 years. And so the answer would be 329.774 or 330. If you didn't know that, what you could do is you could plug in the function 200 times 1 plus alpha y 0.05 over x to the 10x, and then evaluate it for when x becomes a very large number. So let's do, I don't know, 100,000. And when x is 100,000, y is going to be 329.74 or 330. So A is equal to P equal to RT, so in your calculator, the best way to do it is just evaluate A is equal to 200 times E to the 0.05 times 10, or plug in 200 times 1 plus 0.05 over x to the 10x when x gets really big. And you can evaluate that in your table. Alright, 9. What is the value of the limit as x approaches negative 3 of x plus 1 over x minus 2 and x plus 3? So this is another one where it's safest to do this in our calculator. Alpha y, we're going to have x plus 1 in the numerator, and in the denominator we'll have x minus 2 and x plus 3. So we have x plus 1 in the numerator and x minus 2 and x plus 3 in the denominator, and we're going to be looking at the value limit as x approaches negative 3, so we're going to go to table set. Our table start is going to be negative 3, and our delta tables, let's do 0.001. Make it very precise. So even as when x is negative 3, we have an error. When x is negative 2.99, we have 39.88. And when x is equal to negative 3.01, we have 40.12. And so this is going to be, the limit does not exist. So here's why. We plug it into the calculator, and we evaluate at x approaches negative 3. At negative 3, the function does not exist. And then at negative 3.01, the function is going to be approximately equal to negative 40.12. At negative 2.99, the function is going to be equal to approximately equal to 39.88. So notice these values are not continuous. So the function does not, or sorry, the limit does not exist. The limit does not exist. Does not exist, number 9. Alright, we have 4 more problems. What is the value limit as x approaches 5 of 1 over x over 1 minus 1/5 over x minus 5? Once again, plug the function into our calculator, alpha y, and then we do a second fraction. So we do 1 over x minus 1 over 5 over x minus 5. Okay? So now we're going to have our table start at x approaches 5. Our delta table is going to be 0.01, and we graph it. So as x approaches 5, while at 5 we have an error, so this function doesn't exist while x equals 5. As x approaches 5, at 4.99 and 5.01, we have negative 0.04, and on the right hand side we have negative 0.0399, which is essentially negative 0.0401 and negative 0.0399. So essentially this is approaching, this is essentially getting to negative 0.04. Alright? And negative 0.04, let's evaluate our negative numbers in the answer choices now. Negative 1 divided by 25 is negative 0.04. So the answer choice is A, negative 1/25. You could also look at just negative 0.04 math frac and say that negative 0.04 is equal to negative 1/125. So once you find out what the limit approach is in your calculator, just make sure that you can convert that decimal into a fraction to get the right answer choice in the multiple choice test. Alright, number 11. Evaluate. Evaluate the limit as r approaches negative 2 of g of r, as you have negative r squared minus 6r minus 10 right for this function, and r over 2 minus 1 as r approaches negative 2 this function. Let's evaluate this limit with another way in our calculator. Let's put the first function for y1 and the second function for y2. So we'll have negative x squared minus 6x minus 10. So we're going to say plug in as y1, plug in as y2, so that's going to be x over 2 minus 1. And now we're going to look at the function as x approaches number 2. So in table set, our table start will be negative 2. We'll have a small delta table at 0.01. And we'll graph both functions. So let's look at our x's. When x equals negative 2, both functions are equal to negative 2. That's for y1 and y2, which means that the value answer here is going to be a negative 2. So that's, you can say both functions, you can say continuous when x equals continuous at x equals negative 2 at y equals negative 2. So that's the reasoning why this is the case. Also note that you use your calculator. Alright, now you want to evaluate the limit as n approaches infinity of 4n squared minus 5n over 3n squared plus 4. So what we can do is take our calculator, plug in the function alpha y 4x squared minus 5x over 3x squared minus 4. Now, after that, what we can do is we're valuing the limit as n approaches infinity, so we can go to our table set, pick a very large number for a table start. Let's do 500, 1, 2, 3, 500,000. That should be sufficient. And then look at our table. Now when x is 500,000, notice when x gets very big. So our first step is to plug function into calculator. Two, table set, table start, 500,000, and then 3, we evaluate the table. When x equals 500,000, y is equal to 1.333. And we can make the statement as x gets very big, y equals 1.333. So what is 1.33 equivalent to? Well, that's going to be equal to 4/3. Just know that 4/3 is equivalent to 1.333 going on forever. All right, that's number 12. Let's go to number 13. Evaluate the limit as x approaches 2 of 2x squared minus 4x over x squared minus 4. Let's do this last one the good old-fashioned way without the calculator. So, our first step is let's factor everything out first. So we can have the limit as x approaches 2 of 2x, because you can factor to 2x, times x minus 2. And then, in the denominator, we can have x squared minus 4. So this is an a squared minus b squared situation. So we can write this as x plus 2 and x minus 2. Well, clearly with this rational function, the x minus 2's can cancel out to make a whole. So there's a whole at x equals 2. And so then we end up having the function 2x over x plus 2. Now that we've canceled, as x approaches 2, this can be equal to 2 times 2 over 2 plus 2, which is equal to 4 over 4, which is going to be equal to 1. You can prove this with your calculator, but for rational functions, you cancel out and you evaluate at 1. Alright, that's limits.